Hi guys, Jason here. Today we're looking at this beast here. It is a Bad Cat, Hot Cat 100. One of the older ones, right? This is from the Mark Sampson era. That Bad Cat. And this thing, oh, it's an absolute beast of an amp. 100 watt. Look at the size of that power transformer, would you? I mean, it's just enormous. Have a bit of a look at this amp. I'll show you the insides here on camera, but I'll put it on the bench properly so you can have a look at it. This has come in to get the effects loop sorted out. The amp never had one. The amp never had one originally, and one was put into this, as you can see on the rear here, kind of aftermarket. We've got a send level and a send jack, a return level and a return jack for a loop. That's no longer in there. So someone had implemented this with a tube buffered effects loop. There's been an additional 12AX7 hole drilled out to provide a send and return stage. But speaking with the owner, what we're going to do is we're going to implement our super transparent zero loss industry standard LND 150 MOSFET effects loop in here, and we're going to do it in a similar way that I do with the Origin mod, and where we put an effects loop in there, where rather than having the jacks on the effects loop board, the jacks remain on the chassis and we just run fly leads to it. So let's have a bit of a look at this thing, right? I must say it's a work of art, true point to point. Okay, so it's the term, I never use the term hand wired because every amp that's not made with a wave soldering machine and it's clipped together is hand wired in my view. This is point to point construction, right, where you see these tag strip boards like this, and the components, capacitors and resistors, are soldered directly, obviously by hand, onto the tag strips and directly to the pots and so on. And you can see hiding under here, these are our preamp tubes here, right? So V1, V2 under here, V3 or 12AX7s, and then here is the phase inverter. Right, so there's 4 preamp tubes. It's a 2-channel amp, got a clean and a gain, and so these first 3 12AX7s here with 6 triodes is used for the gain staging, phase inverter here, and then a quad of EL34s here, which are cathode bias. Okay, this is not a fixed bias amp. There is no adjustable bias in here. So just like the Hot Cat 30, which there is a schematic on the internet for the Hot Cat 30, this amp to me looks the same, other than it's 100, right? I haven't kind of matched it component for component, but looking at the general architecture of this thing, in terms of how the clean and the gain channels are set up and how they both come together at the phase inverter, and a cathode bias power section, it looks very, very similar to me. All the stuff down here is obviously, this is the power supply filtering. Okay, this chassis mounted resistor here is part of the screen supply network. So coming off the screen supply node here, we do have screen grid resistors, right, on all of these 4, but they are fed off this. Right, it's not a choke. The amp actually has a filter choke. You can kind of see here, this is where there's some funky stuff going on with the loop, which was put in aftermarket, and the switch here. So I kind of traced some of this out. But basically what's happening is these channels are completely separate, the clean and the gain channel. They only come together at the phase inverter. And it's a really interesting design because the amp has no negative feedback at all. Right? There's no negative feedback line that comes back into the phase inverter. So what they did is they've got the clean channel, which is, this is the clean volume here, it's coming in, this black wire here, it's coming into the phase inverter on this side. Okay, and the gain channel is coming into the phase inverter on the other side. And you can see this in the Hotcat 30 scheme. It's the same setup, and this amp's the same, right? And the input onto this side of the phase inverter for the gain channel is fed from this master volume pot over here. This is the treble pot. The treble pot comes across and feeds into the master, and then this master comes down and it comes into this tag strip here, where previously it would have, I'm assuming, been wired into this switch, right? This is where the old effects loop would have been. That was added in aftermarket. This is not used, this tag strip here. This tube socket here is not used, and the switch is not used. So you can imagine this must have been wired up somehow as a tube buffered effects loop. You can see this black shielded coax here comes in into the send. So the effects loop is actually, you know, like the send and return jacks are actually in circuit, but they're not buffered in any way. So this effects loop would be, if you tried to use it, it'd be pretty ordinary. And you can see this cap here, right? This cap here is coming straight off the return jack. This is a return jack right here for the effects loop. So if you plugged into the return jack in here, you're basically coming in unbuffered straight into the input of the phase inverter. So you want to be pretty careful about what you plugged into that if you didn't want to go deaf, because you're coming straight into the power amp without it being attenuated or in any kind of control. It would need a line level signal, a pretty hot signal to come in here to drive it. So the elements are here for me to be able to use, and what we're going to do is use, as I said, one of my boards, and I'm going to mount it in here. Kind of like, as I said, like I do with an Origin, or I've done this a few times where, because there's already chassis mounted sockets in place, and the spacings of course don't match my board. My board is a standard 1.5 inch, right? 1.5 inch from send and return, standard Marshall measurements in terms of speaker jack separation, and which we replicate with the loop, and they don't line up, and I do not want to drill more holes in this chassis, right? So I'm going to put this on some standoffs just like so, and we'll have an LND 150 driven loop. It should be killer. The loop will only work on the gain channel, right? Because we've got these two inputs coming in, clean channel to the phase inverter here, and this one here is a gain channel. Spoken with the owner Charles, and he only wants to loop on the gain channel, not interested in the clean channel at all, which is cool. So that's what we're going to do. All right, so let me just take you through how I've put this in, right? So this is one of my standard loops, as I mentioned, and I've got this thing set on a standoff, and I use one of the ground lugs here to solder a piece of bus wire onto this unused tag strip. So the loop is solid as, really solid in there. And just what I want to do is just kind of go through the signal path of how I wired this in to this amp, because where you want to put an effects loop is pretty standard, right, in all these amps. And it's kind of, you know, after the treble wiper, which in this amp is right here. It's the treble pot. And before the phase inverter input, which, as I said previously, was here, right, for the gain channel. And each amp, you know, they can be a little bit different in how this is configured. In this amp, close inspection, what we have coming off the treble pot here is a 220k resistor. It's this one right here. And from there, that's actually making its way to what would have been directly to the phase inverter. So imagine there's no loop here. You come straight from this 220k resistor off the treble wiper into the phase inverter, and the master volume, if you look at this master volume pot carefully, you can see only two lugs are connected. So this master pot is just attenuating the signal back to ground. So it's connected off this 220k. And what this means effectively is that we have a master volume is now before the loop. Okay, it's pretty common in a multi-channel amp where you have channel volumes. When you put an effects loop in, or when you use your effects loop, your channel volume is your send level out the loop, right? Because this master volume is setting how much signal is going to hit the input of the loop, which is now coming in here. Okay. And then the return volume, which is on the rear of the amp, which is this pot right here, which I've set as a 250k audio taper pot. This is the volume after the loop. So your signal comes into the loop here, onto the loop board. Okay, it gets buffered and converted into effectively a low impedance signal, and it comes out the send jack, which is this coax here, which is connected to the send jack right here. Out the loop, back in through the return jack, which is right here, and this coax here now, this black one here, comes on to where the return is on the loop, and from there, I get a bare board, you'll see the send and return on here, right? So I'm coming off the send on these 2 points. So this is the signal, this is the ground, and then on the return, this is the signal here, and this is the ground. So that's how those coax wires are connected in. As I said, you know, this is how I do it on the Origin or any amp where I need to just, you know, mount the board on a standoff or two standoffs rather than being able to mount it with the jacks. So your signal comes back off the return jack onto the board, and then it comes out of the loop stage, this coax here, and it's out our return volume pot, and then the phase inverter, input to the phase inverter straight off the wiper of that pot. So if I just tilt the camera forward here, we might get a better view of how that's connected on the jacks. The other thing you need to do, of course, with these loops is you need to power them. And they take, you can see it on the board here, they take a B plus signal here, or not signal, B plus line is your high voltage DC. Okay, and they also need a ground reference. And for this install, and I can't always do it right, I kind of take the power off the phase inverter node, the phase inverter supply node. This is our phase inverter here. This point in the amp right here. There's two 100k resistors. These are the plate resistors for the phase inverter in this amp. In a Marshall, you'd see 100k and 82k. Yeah, this amp's 100k and 100k plates on the phase inverter, and they connect to this node right here, which connects right back into filter cap. I think it's this one right here, this node here. Okay. By the way, I should have mentioned it in the first run through. These four huge big resistors here, these are the cathode resistors for the EL34s. When I said it's cathode bias, all right, so each EL34 has its own cathode resistor. They're not shared, and sitting underneath them are the bypass caps for each of those cathode resistors. So there's 4 resistors, 4 bypass caps. Plate voltage, by the way, here guys, measure the plate voltage here. It's about 410 volts on pin 3, and the voltage at the cathode resistor is 22 volts. So those who are so inclined can do cathode bias calculation using those data points, right? 270 ohm resistor, 22 volts, and 410 on the plates. Put it in the comments in the video if you're so inclined, right? I'd like to see how you guys do it. Do your calculation. Let me know what you think the bias at idle is for these power tubes. So guys, loop's in. I have tested it. One of the things that I needed to adjust and kind of tweak, if you like, with the install is getting the send level out. That is kind of not, well, hot enough but not too hot. So I use my H9, and anyone's got an H9 will know that it comes with a pretty useful app on your phone where you can actually look at the signal gain that's coming in. And what I'm looking for here is effectively when this master volume, which is my send level, is up at, you know, midday, 1 p.m, 2 p.m, around there somewhere, that I've got a nice, you know, nice signal level that's coming into that pedal that's either not too weak or not too strong. And I adjusted that by setting this resistor here. I've set it on a 100k. You'll often see in these LND 150 effects loops, you might see 2 meg 2 here or 470k. You can adjust this guy. On my board, it is R2. Anyone's using a headfirst loop. If you're not getting enough signal out, signal level through your send, I should say, you can move this down. 100k is probably as low as you'd ever need to go. And if it's too hot, move that up anywhere up to 2 meg 2. So I've tested the loop, sounding fantastic. Let's take this into the main room and we'll crank the amp up and we'll try something in the loop with it and see how it sounds.